Okay, so let's see that how we will solve the heat equation using Crank-Nicolson method. So this is the problem that ut equals to uxx, where this is the boundary condition, and this is initial condition. So we have to solve this ut equals to uxx using Crank-Nicolson method by the step size pi by 10 and 0.005 in the time direction. So we have to compute it at 0.5, but let's evaluate only at the first level. So here is the scheme diagram that we are going to use. So this is your 0, this is pi by 10, this is 2 pi, this is pi by 10, this is 2 pi by 10, this is 3 pi by 10, this is 4 pi by 10, 5 pi by 10, 6 pi by 10, 7 pi by 10, 8 pi by 10, 9 pi by 10, and pi. And this is your 0.005, this is 0.01, this is 0.15. So this is your pi by 10, this is your 9 pi by 10, and this is 0.005. So 0.005. Okay, so in the same way it will go up there. Now see, now the initial condition is given as the sin x and the boundary condition is given 0. So what it means that on this way, here that u is equals to 0, and again here also u is equals to 0 given. So in this way u is equals to 0 is given, and the initial condition is given sin x. So let's compute we'll use the initial condition for computing at 0th level. So we'll compute so what's the value? Let me calculate it. Sin x start from 0 and pi. Yes, so this value is of course 0, so this is 0. At this point it is 0.30902, at this point it is 0.58779. At this point 0.80902, at this point 0.95106, at this point it is 1, and again 0.95016, 106, and again it will repeat here. Okay. So this is the scenario. Now so let me write first the FDMX scheme for this Crank-Nicolson method. So it's so R is given as C square K by H square. So this point is your, let's say, minus r, this is your 2 plus 2r, and this is your minus r, this is your r, this is 2 minus 2r, and this is r. Okay, so what it is that minus r ui n plus 1 plus 2 plus 2r I minus, this is I minus 1, this is I n plus 1 minus r u I plus 1 into n plus 1, this is equals to r u I minus 1 at nth level plus 2 minus 2r into u I nth level plus r u I plus 1 at nth level. Okay, so this is the scheme, the formula that we are going to use. So see, we know the value at this point from the last diagram. If you see the last diagram, we know value at this point. See the last point, the values at this point we know, the values at this point we know, the values at this point we know, and we are supposed to find the values at this point, this point, this point, this point, and this point. After that, this all will repeat. After that, this all will repeat. This all will repeat. So only we will have to find the half of the value, and after that all will repeat. Yes. So this is the scheme. So if you write it in the matrix form, so how it will looks like, it will be 2 plus 2r minus r 0 0 minus r 2 plus 2r minus r, then 0. Similarly it will come, and it will come minus r and 2 plus 2r. This, let me write u1, u2, u9, and if you write the right hand side matrix, so it will be, since the boundary conditions are given 0, so we'll just consider this only. So r, sorry, 2 minus 2r, r 0, and r 2 minus 2r, r 0, and in the same way here will come 0, and r and 2 plus 2 minus 2r. So this is also 9 by 9 matrix, this is also 9 by 9, so 9 cross 9 matrix, and this is also 9 cross 9 matrix. But we can reduce this matrix to 5 cross 5. Why? Because see from the last diagram, this is your u1, u2, u3, u4, u5. Now this is nothing but u4, this is u3, this is u2, and this is u1. So instead of writing 9 by 9 matrix, we can reduce this matrix to 5 by 5 matrix. So let's see how we'll do that. So this is your u1 into this, u2 into this, so this will remain same, this will remain same, this will remain same, so till 5th level will here. So let's see that how the matrix will look like. So the let's first write the equation, all the equation, then we'll see that how it will look like. So it will be 2 plus 2r into u1 minus r into u2 plus 0 into u3 plus 0 into u4 plus 0 into u5 is equals to something that will compute later on. Now this minus r into u1 plus 2 plus 2r u2 minus r into u3 again plus 0 u4 plus 0 u5, that will compute later, and similarly minus 0 u1 minus r u2 plus 2 plus 2r u3 minus r u4, and again plus minus plus 0 u5 is equals to again something 0 u1 plus 0 u2 minus r u3 plus 2 plus 2r u4 minus r u5. So this will be something, and again 0 u1 plus 0 u2 plus 0 u3 minus r u4 plus 2 plus 2r u5, and again we will write minus r u6 equal to something. But see, this is nothing but, as we have explained, this is nothing but minus r4, so this will be this 2 will make you minus 2r u4. So now we have a matrix which is in this form. We have a matrix called two plus 2r minus r 0 0 0 minus r 2 plus 2r minus r 0 0 0 minus r 2 plus 2r minus r 0 0 0 minus r 2 plus 2r minus r 0 0 0 minus 2r and 2r plus 2. 2r plus 2. Yes, and this will give me u1, u2, u3, u4, u5, and this is equals to something that we will compute now. This also I'll tell. Yeah. So this is the scenario that we are going to solve. Now let's compute the right hand side. So let's go to the previous. Yes. So see what it is telling: r into I minus 1n, 2 minus 2r into in, and r into this. So what we will do, so suppose that we want to find at the what is the value at this point. So we'll go to the r into this, means r into 0. So at this point will be r into 0 plus 2 minus 2r into this into 0.30902 2 plus r into 0.58779. So this will come something. Again, if you want to compute at this, so r into this, again plus 2 minus 2r into this, and plus r into this. If you want to compute this, so just take this r into this, r into this, r into this, and 2 plus 2r into this. So again, in the similar way, we can compute till u5. Till u5 you can compute it. Yeah, there is an easy way to compute. If we have FX991ES plus calculator, then I'll tell you the steps. If you have FX991ES, suppose that you have the calculator FX991ES plus. So FX991ES plus, then you can compute it easily. So first you erase your memory, so you just shift and then press 9. A pop-up will come, so you enter 2, that is memory, and then clear memory, so you add equals to, and then yes, completed. So now you have setted you have erased everything from your data. Yeah. Now what you will do, you now see r is equals to here, r is equals to c square k by h square. So if you compute it, the r is coming 0.050661, 0.050661. So this is your r. Now in the calculator, what we will do, we'll write 0.050661 into a, and how we'll get a? So just compute alpha and a. So for getting there is called alpha plus this. The minus sign is there, something called. I'll show you the, I'll give a pic of this. Plus 2 minus 2 into this number 0.050661 into b. In the same way, alpha and minus, alpha and this b is there. B is just near to a, plus 0.050661 into c. After that, you compute the calc button. After that, after inserting this, you just, after this, you input your calc. You just press calc. Okay, and then, so let me write it. So 2 minus 2 b plus. So he will ask for a. So he will ask for a, and the value is so 0.0000. So you just press your a equals to 0. See, a equals to, yeah. So you just press, this is your, initially this is your a, this is your b, and this is your c. So you just press a equals to 0, b equals to 0.30902, and C equals to 0.58779. So you will get your you will get answer as 0.616502. So you're getting 616,502. After that, you again press equals to. Again he will ask for A, B and C. Now your A, B and C has been changed. So A has changed to B and B has changed to C. Yeah. So for the second, this will be your A. So for the second, this will be your A, this is your B and this is your C. So in place of A we'll put 0.30902, in place of B we'll put 0.58779, and in place of C we'll put 0.80902. So it will give 1.17. So it will give 1.17 2655. Again in the similar way, if you calculate, it will give 1.614022. This will be 1.89739.8, and this will be 1.99541. Now we have a system 5 cross 5, which is a tridiagonal system. So we can use Thomas algorithm for solving this. So we can use your Thomas algorithm for solving this. So we can use Thomas algorithm for solving the system. So I'm just writing the answer for this. So you'll get your U5 is equals to, after solving, after applying the Thomas algorithm, you'll get U5 is equals to 0.99505, U4 equals to 0.94635, U3 equals to 0.80502, and U2 equals to 0.58402, and U1 equals to 0.30749. So these are the values, and hence your U6, this will be your U6, this will be your U7, this will be your U8, and this will be your U9. In the same way, we can compute at time level, second time level, third time level, fourth time level, and subsequent time levels we can compute. So this will save your time and as well as calculations. Okay. So now we will see the because I have explained the calculator stuff, but I think it might not be clear, so I'll show it again for the calculator stuff, that how will you do the computation of the right hand side matrix, this matrix. So this is the computation of this right hand side matrix. We'll just do this, that how we'll compute this right hand side matrix.